Hello everyone and welcome to another News Coolum video. You could call it a plug side chat. Not really a plug side chat. I'm just charging up a little bit while I'm down here shopping. This is the EV Go over at the Black Bear. I didn't want to bother, even though I'd be able to do two things at one time. I didn't want to bother charging at the Electrify America at the Walmart when I'm in there shopping, just because there are already two cars parked there, and I don't want to have to deal with blocking a charger and then being in there charging and making sure the app works and all of that. So you all have heard my experiences, but this isn't so much a plug side chat as it is. I want to start doing some regular updates on the solar system that I'm installing. And one of the reasons that I'm here is right now my Volt is plugged into the solar, charging up, so I wasn't able to charge this up, so I figured I would just run down here and charge at this EV Go before I do a little bit of shopping for some pet food and some things like that. But one of the things that I have gotten done, and I'll just talk through it, but I have a bunch of B-roll that I'll show. I think actual time, it took me about 2 days to put together the EEL V5 DIY battery box. So for this build, because I have two of these EEL V5 DIY boxes, this first build I did with 16 of the EVE LF304 cells. I think I have mentioned them in another video that I had them. So I went ahead and used those 16 cells. The next box that I build, because like I said, I bought two of them, I'll be building with the MB31, which are slightly bigger. So the LF304 have a stated capacity of 304 amp hours. Tested, they usually are somewhere around 310, 315. And then, of course, the MB31s, I think, are rated officially at a 310 amp hour, but they're really closer to a 330 amp hour battery cell. So a significant bump up, not quite 10%, but a significant bump up. So that will be the next build that I end up doing. So this one, though, was the LF304. And, I think the build went fine. I haven't really had a chance to use the battery enough yet to give my take on how it's working, right? I'll no spoilers. I'm working on some other aspects of the solar system, and this particular battery will just be the first one, right, as constructed with 16 of these EVE LF304 batteries. The entire battery pack has a capacity of over 15 kilowatt hours. So the two of these EEL V5 DIY battery pack kits will combine to have about a 30 kilowatt hour capacity, a little bit more than that. And so actually they're basically combined. The two stationary batteries are going to be the equivalent of about half the total capacity of this Chevy Bolt EV, right, that I'm driving. And so in terms of, if I'm just purely looking at it as a means of charging up my EV, these batteries alone will be more than sufficient. But they're going to be running a larger inverter that's going to be running a house. So I just wanted to kind of walk through as I constructed this kit and maybe give a little bit of a forewarning if anyone's going to buy one, right? And so I think the two big pet peeves that I have with these kits are, first, just minor thing, they need to come with a diagram, right? So I ended up packing the battery cells in the wrong order the first time because it wasn't clear where the bus bar terminals were going to be. And it's essentially, the construction, right, is two columns, and so you're basically bridging two 8-cell groups, but I had them flipped around, and it's easy enough to address that, right? You just pull one of the cells out of the back and then just shove the row down, and then you've basically fixed it, right? You've flipped the cell's orientation. So just having like a printout of a basic diagram, I think with the instructions would be very, very helpful. But the other thing that EEL did that I think it really bothered me is because I bought from their store directly, and they primarily sell the 2-stud or 2-screw terminal LFP cells. And so what that means is they require a different bus bar, and each terminal that you screw down on the battery cell is going to have 2 different screws or lugs to hold it down. And all of the batteries that I have are the single lug. And there was no specification, there is no option on the EEL store when buying the DIY kit. Do you want the single stud or do you want the dual stud terminal posts? Like I said, the batteries that they're selling at their store are primarily the dual stud. So I don't know if that's just their default and you have to do something special to order it. And part of it, now that I'm thinking back on it, I think my order didn't go through and they had to process it manually. And so maybe I did specify when I ordered it. So maybe I shouldn't be too harsh on them. I don't remember the order page now. Maybe they did actually have the option for the single stud that I selected, but it didn't get translated because the order ended up, you know, my fraud security canceled the order, so they ended up having to process it manually. So there could have just been a disconnect there. But the bus bars actually still work for a majority of them, except for the ones that bridge the 2 cell groups together. And for that, I have bus bars, so I just went ahead and used my standard bus bar that came with my battery cells. But the EEL kit actually comes with terminaled BMS wires. So essentially they use an M3 screw that you're able to screw directly into the bus bar, and it's just a really good clean connection for making sure that your BMS is hooked up and getting the right voltage reading out of the cell. The problem with that, though, is that, again, that needing to replace the bus bar to bridge the 2 cell groups, I ended up having to drill and tap a separate M3 screw. I didn't have a tap kit at the time, so I just ended up using just a regular sheet metal screw, and then of course I had to cut it off because it was too long, right through the terminal. It would have reached the top of the cells. So I went ahead and made those screw holes through, and then of course after I finished constructing everything, the big problem was the final boss, the final bus bars, the main negative, main positive. They basically had to be bent to match the cells, and you know, the copper is easy enough to bend, so that wasn't really an issue, other than it popped one of those pre-tapped BMS terminal screws out, and then I had to do another one of my sheet metal screws just to the self-tapping screws, just to put the other, I think it was the final number 1 positive for the BMS. So I ended up having to screw that in myself. But otherwise, everything, you know, put together fine. I didn't end up putting the kit does come with a built-in fire extinguisher. I didn't end up putting that one in. I believe that one was going to actually require me to drill holes into the case to screw it in, because I don't think there was any mounting points that I could see. This kit also comes with the Cephalos BMS, which is a little bit rudimentary compared to something like a JK or a JBD BMS. But from what I can see, it works fine. They have two different lead cables, so you can't really screw up and get the BMS out of order based on the cells. And it has all of the basic readings that I want. It's preset for a 280 amp hour battery, but the whole capacity thing with the batteries doesn't really matter all that much, because I think within LFP, even 5 years ago, the 280 amp hour cells that you would buy were often, capable of outputting 290, 295, almost 300 amp hours. So it's almost just it's academic, right? That's just a setting that they have for the 280 amp hour. But I know that I have significantly more than that, about 10 to 20% more energy, especially 20% probably when I put the MB31 kit together, which I'll also do any updates if anything untoward happens with that. But yeah, the kit went together. I think the final fit and finish is maybe wanting a little bit. Some of the screws were a little bit hard to get in, even though they were pre-tapped. I feel like there was a little bit of cross-threading, and I had to put a lot of energy into screwing them down. So they come with two. That's the yellow polyurethane sheets as insulation. Those are pretty simple, straightforward. They're mostly meant to isolate the cells from the inside of the case walls. But then there's also that EVE tape that it's a foam that you place between the cells. So all of these cells have to be under some amount of compression. And that EVE tape has like an adhesive side to it that you can peel off. I chose not to, just because I didn't know if and it's good that I didn't, because I did end up having to reorganize the cells. I just tried to center it as best I could. Turns out that I didn't quite center it as well as I wanted to, and I might, the next build I do, I might actually just apply the adhesive, because you have to be very careful to make sure that the sheets are directly in the center of the cell, because they are so much smaller. This kit also comes with these translucent silicon spacers, which kind of defeat the purpose of the EVE tape. But I can see why they do it. They do it to even out the cells so that everything, everything is spaced properly. But they're really not that necessary. So doing it over again, I might pull the adhesive on the EVE tape and put it directly in the center of the cells, but probably not. And then also, one of the other tricks that I figured out, because putting that final compression plate on, the cells were just too far out, right? Like even trying to physically push them in, there's just no way to get a thread bite with the screws and the bolts that they provided. They're just too short. So what I figured out is I can actually lift the case up on its end, right? Because I was constructing it on a dolly so that I could move it after I'd finished building it, and placing it vertical, and the weight of the cells themselves were enough to compress that foam tape between the cells enough that I was able to get that final compression plate in place, and then start to screw it down and then torque those nuts down. Other than that, yeah, not a whole lot unexpected. Like I said, there's some things I like about the kit. There's some things that I don't like about it. It was not super expensive, but I think the big thing is having the correct bus bar kit would be nice. And EEL does have the single stud bus bar kit. available for purchase, but it's something like $60 or $70 to buy that kit. And it's, like I said, if you're willing to do a little bit of customizing to the bus bars, it's not, like, strictly speaking, necessary or required. So I would personally, I would just make sure that you buy the kit and specify the bus bars that are, necessary for the battery cells that you're using. And if they screw up after you specified, then you can just maybe get them to send you a bus bar kit for free, right? Whereas, like I said, I don't think that I specified, so it's not necessarily worth it for me to raise a whole lot of cane over it. So, but yeah, just make sure that it matches, and then I will keep everyone updated on how well this one is working. I'll probably need to mark the battery case, just so I don't get them mixed up, right? Which one is the MB31 versus the LF304. So the other thing too that I've noticed, maybe it is that the battery prices are still dropping. When I go through and how much I ended up paying to put this kit together, I want to say it was about $1,700, right? Including shipping and tax, maybe $100, somewhere between $1,700 and $1,800 per kit. One for the 304 and one for the MB31. And that includes the cell costs. But you can basically buy a kit for about that already pre-built. The only difference is you might not be getting the same cells with the same cell capacity, but then and it wouldn't necessarily be the EEL. There's a number of different pre-built battery kits like this. There are some that are vertical stacked, that are on rollers, that are maybe fit the space that you're using a little bit better. That's the other thing too, is, like I said, I built this on a dolly. If you build this on the ground, just understand how heavy this is going to be when it's done. So, like, if you're working in a garage or a hard space, like a flat hard concrete, you could probably build it on like furniture dollies or something like that. It's not super heavy, but it's heavy enough that one person can't pick it up. And I say that in that it's awkward to pick up. I was able to move it pretty easily, like I said, between the dolly and the handles that are built into the side. I just would not trust those handles to be able to hold 50% of the weight. And there are 4 handles, so I think it would probably be reasonable for 2 people to move a kit like that, but using all 4 handles at the same time, and then being careful about it too. Because, like I said, when you actually tally up how much the case weighs total, it is well over 200 pounds with the battery cells. And the case, even without the battery cells, because of the size, is just an awkward weight to carry. The case itself is probably another 40 or 50 pounds. Maybe that's including the boxes and the bus bars and all of that. But with the batteries installed, over 200 pounds. So yeah, I would say you probably don't want to try to move it or pick it up on your own, even with 2 people. The handles might hold, but I would be a little bit concerned about just holding up that much weight only using the handles. So just be forewarned about that. And then, like I said, it does come with a built-in power switch, but built-in circuit breaker. The system that I'm going to put together will have an additional circuit breaker and bus bar to link it to the inverter. So I have some more updates that I'll be doing in the near future, but I just wanted to give just a run through of like I said, that my build of the EEL V5 DIY battery kit for, I think they just listed as the 280 amp hour, but it goes all the way up to like the 310 to 314 amp hour class of batteries. Yeah, let me know if you have any questions. You know, like I said, overall my experience was fairly good, other than the screw up with the bus bar kit being the wrong one. And like I said, it just would be really nice if they included just some sort of a diagram. I had to go online and search and then try to find the right one for the EEL. And then this Cephalos BMS seems like it's a little bit like rudimentary and basic. So I want to make sure too that I get all of the settings right in terms of the low voltage cutoff. You know, a lot of the presets are probably okay. Just the current limit, the charging voltage limit, and the low voltage cutoff limit. And then of course, it does come with a number of temperature sensors inside, and the the low temperature cutoff, just making sure that that's working. And LFP can be very sensitive to temperature, and I haven't really solutioned for the shed where these batteries will be housed yet exactly how I'm going to ensure that they stay warm during winter, because right now that shed will easily get down below 30 degrees during winter time. So I want to make sure that the batteries don't have to shut off during winter just because the shed is too cold. So I'll be coming up with that solution as well. So yeah, just stay tuned. Let me know what you're interested in what I'm doing right now with this solar project. Like I said, I know a lot of people have given me feedback about what I should and shouldn't be doing, and that while that's great, I also do want people to understand that the way I'm doing this is probably not ideal. It's because I'm treating it almost more as a self-proctored class, if you will. I'm sort of teaching myself as I go along, so I'm experimenting and doing some research, and then just kind of sharing with everybody what I'm going through. And then of course there's one other major suggestion that came through from people on the F-3800, the Anker F-3800, and while it was a great suggestion, I think Anker is on to everybody. So what people suggested is to use one of these LFP batteries, these 48 volt LFP batteries, and feed it through the Anker battery cable, right? So Anker provides these expansion batteries for the F-3800. They're LFP, same size, same everything with the Anker system. And if you get one of those cables, you can actually modify it to hook it up to any LFP 48 volt battery. The problem is those cables are sold out everywhere. And so, like I said, I think, and even the Anker store, they're not selling the cable individually. You can literally only buy it if you spend, $2,000 or whatever on their, 5 kilowatt hour expansion pack. So, I mean, if anybody knows a source for where those cables can be found, that would be great, because right now it looks like Anker isn't even doing replacement cables, right? If you have one of those systems with a expansion pack and a cable, take care of that cable, because it looks like Anker is is not selling any more of them. So I think they know that people were able to bypass buying their proprietary battery system and just going with their own LFP instead. And so now, from what I can see, they're not available anywhere. So, like I said, if anybody knows where they are, let me know. But right now, that's not really an option, because it would be a great one. I could just hook this EEL V5 battery directly up to that Anker, and it would work well, right? That's literally tripling the or adding 15 kilowatt hours to basically a 4 kilowatt hour battery pack. So anyway, that's it for now. I'll have some more solar project updates soon. And thank you all for watching.